Chemistry of soil. Soil is the thin layer of material covering the Earth's surface and is formed from the weathering of rocks. It is made up mainly of mineral particles, organic materials, air, water, and living organisms, all of which interact slowly yet constantly. Therefore, most living things on land depend on soil for their existence. What are the different types of soil? Soil is a natural resource that can be categorized into different soil types, each with distinct characteristics that provide growing benefits and limitations. Soil can be categorized into sand, clay, silt, peat, chalk, and loam. Sandy soil is light, warm, dry, and tends to be acidic and low in nutrients. Sand soils are often known as light soils due to their high proportion of sand and a little clay. These soils have quick water drainage and are easy to work with. They are quicker to warm up in spring than clay soils but tend to dry out in summer and suffer from low nutrients that are washed away by rain. The addition of organic matter can help give plants an additional boost of nutrients by improving the nutrient and water holding capacity of the soil. Clay soil is a heavy soil type that benefits from high nutrients. Clay soils remain wet and cold in winter and dry out in summer. These soils are made of over 25% clay, and because of spaces between clay particles, clay soils hold a high amount of water. Because of these soils drain slowly and take longer to warm up in summer, combined with drying out and cracking in summer, they can often test gardeners. Silt soil is light and moisture-retentive soil type, with a high fertility rating. As silt soils comprise medium-sized particles, they are well-drained and hold moisture well. As the particles are fine, they can be easily compacted and are prone to washing away by rain. By adding organic matter, the silt particles can be bound into more stable clumps. Peat soil is high in organic matter and retains a large amount of moisture. This type of soil is rarely found in a garden. It is often imported into a garden to provide an optimum soil base for planting. Chalk soil can be either light or heavy, but always highly alkaline due to the calcium carbonate within its structure. As these soils are alkaline, they will not support the growth of ericaceous plants that require acidic soils to grow. If chalky soils show signs of visible white lumps, then they can be acidified. Loam is a mixture of sand, silt, and clay that are combined to avoid the negative effects of each type. These soils are fertile, easy to work with, and provide good drainage. Depending on their predominant composition, they can be either sandy or clay loam. As the soils are perfect balance of soil particles, they are considered to be the gardener's best friend, but still benefit from topping up with the additional organic matter. What are the properties of soil? Soil has a various types of properties. These are physical, chemical, and biological properties. Physical properties stabilize soil properties like texture, water holding capacity, and color. Soil has a various types of texture, such as sand, silt, and clay. Soil texture and structure influence porosity by determining the size, number, and interconnection of pores. Clay soil has more water holding capacity than sandy soil. It is because there is more pore size in the sand than in clay. The soil chemical properties include pH, salinity, and organic matter. pH is the measure of the acidity or alkalinity and hydrogen ion concentration. Low pH, that is 2 to 4, allows the growth of plants, and high pH soil restricts the growth of plants. Saline soils contain a high amount of soluble salts, primarily calcium, magnesium, and potassium. On the other hand, sodic soils areas are dominated by sodium. Saline sodic soils have both high salt and sodium content. Salts in the soil can affect its structure and porosity. Organic matter contains residue and metabolism from plants and animals. Upon decomposition, it acts as a good fertilizer to crops. Soil also contains living organisms that includes both micro and macro plants and animals. Soil microbes convert organic matter into utilizable forms such as ammonia, sulfates, and phosphate. Bacteria, fungi, and actinomycetes are some examples of microorganisms that live in soils. Nematodes and earthworms are examples of animals that live in soils. There are also rodents, such as prairie dogs, moles, and gophers. There are also arthropods, such as mites, insects, and spiders. And lastly, the gastropods, such as slugs and snails. Most plants get their nutrients from the soil, and they are the main source of food for humans, animals, and birds. Therefore, most living things on land depend on soil for their existence. Soil is a valuable resource that needs to be carefully managed as it is easily damaged, washed, or blown away. If we understand soil and manage it properly, we will avoid destroying one of the essential building blocks of our environment and our food security. Soils develop over time. Layers or horizons form a soil profile. Most soil profiles cover the earth as two main layers, the topsoil and the subsoil. Soil horizons are the layers in the soil as you move down the soil profile. A soil profile may have soil horizons that are easy or difficult to distinguish. Soils exhibit three main horizons. These are A, B, and C horizons. Some soils also have an O horizon, mainly consisting of plant litter that has accumulated on the soil surface. The properties of horizons are used to distinguish between soils and determine the land use potential. A horizon. It is humus-rich topsoil where nutrient, organic matter, and biological activity are highest. For example, most plant roots, earthworms, insects, and microorganisms are active. The A horizon is usually darker than the other horizons because of the organic materials. B horizon. It is the clay-rich subsoil. This horizon is often less fertile than the topsoil, but holds more moisture. It generally has the lighter color and less biological activity than the A horizon. Texture may be heavier than A horizon too. The C horizon. It is the underlying weathered rock from which the A and B horizons form. Factors affecting soil formation. Soils form continuously but slowly, from the gradual breakdown of rocks through weathering. Weathering can be physical, chemical, or biological process. Physical weathering is the breakdown of rocks from the result of mechanical action. Temperature changes, abrasion when rocks collide with each other, or frost can all cause rocks to break down. Chemical weathering is the breakdown of rocks through a change in their chemical makeup. This can happen when the minerals within rocks react with water, air, or other chemicals. Biological weathering is the breakdown of rocks by living things. By burying animals, it helps water and air get into rock, and plant roots can grow into cracks in the rock, making it split. The five main interacting factors affect the formation of soil are parent material, living organisms, climate, topography, and time. Parent materials. Soil minerals form the basis of soil are produced from rocks through the process of weathering and natural erosion. Water, wind, temperature change, gravity, chemical interaction, living organisms, and pressure differences all help break down parent material. The types of parent materials and the condition under which they break down will influence the properties of the soil formed. For example, soils formed from granite are often sandy and infertile, whereas basalt under moist conditions break down to form fertile or clay soils. Organisms. Soil formation is influenced by organisms such as plants, microorganisms such as bacteria or fungi, burying insects, animals, and humans. As soil forms, plant begins to grow in it. The plants mature, die, and new one takes their place. Their leaves and roots are added to the soil. Animals eat plants and their waste and eventually their bodies are added. This begins to change the soil. Bacteria, fungi, worms, and other burrowers break down the plant litter and animal waste and remain to eventually become organic matter. This may take the form of peat, humus, or charcoal. Climate. Temperature affects the rate of weathering and organic decomposition. With a colder and drier climate, this process can be slow, but with heat and moisture, they are relatively rapid. Rainfall dissolves some of the soil materials and holds others in suspension. The water carries or leaches these materials down through the soil. Over time, this process can change the soil, making it less fertile. Topography. The shape, length, and grade of a slope affect drainage. The aspect of a slope determines the type of vegetation and indicates the amount of rainfall received. These factors change the way soils form. Soil materials are progressively moved within the natural landscape by the action of water, gravity, and wind. For example, heavy rains erode soils from the hills to lower areas, forming deep soils. The soils left on steep hills are usually shallow. That are transported soils include alluvial, the water transported, colluvial, the gravity transported, and the aeolian, which is the wind transported soils. Time. Soil properties may vary depending on how long the soil has been weathered. Minerals from the rocks are further weathered to form materials such as clays and oxide of iron and aluminum.